information using visible light and something called total internal reflection. It works by bouncing waves off the sides of a thin piece of plastic or glass until it emerges at the end. Total internal reflection can only happen when the light is travelling from a denser substance, like plastic, to a less dense one like air. Whether total internal reflection will occur depends on whether the angle of incidence is greater than the critical angle. If the angle of incidence is less than the critical angle, then most of the light passes out, but a little bit is internally reflected. As you increase the angle of incidence, more light gets internally reflected, and less light is refracted out. Once the angle of incidence is greater than the critical angle, no light is refracted and all of the light is internally reflected, creating total internal reflection. Different materials have different critical angles, and it depends on the refractive index. They are related by this formula, where the refractive index is 1 over sine of the critical angle. For example, diamond has a refractive index of 2.419. By rearranging the equation, we can work out its critical angle of 24.4 degrees. As I mentioned earlier, total internal reflection is used in optical fibres, which are very useful for transferring information over long distances very quickly, such as your broadband. They are also used as little cameras in keyhole surgery, so that the surgeon can see what they are doing without the need to cut a big hole in someone.